This conference will now be recorded.
Okay, so howdy, welcome to our first 2021 publication series. This is our capacity building professional development that we do between the ELRC and Credella. The purpose of this is to look at publications, grants, and research methods. Today, we have Dr. Shifang Tang. Shifang is a LISTO coordinator and a researcher. She teaches research methods class at A&M as well. And today she's going to talk about experimental sometimes called quasi experimental design and evaluation from the perspectives of the What Works Clearinghouse standards. So I'll go ahead and give you, make you the presenter, Shifang.
Hi, can you hear me?
Yes, we can hear you.
Okay, great.
And just a reminder that if you're not presenting, go ahead and mute your mics for me, please.
Okay, so today we will talk about experimental and quasi-experimental design and evaluation from the perspectives of WWC standards. So, firstly, I want to show you a flow chart that WWC used for evaluating RCT and QED and determine whether those studies can receive 3 ratings eligible to meet WWC group design standards without reservation, with reservation, and does not meet WWC group design standards. So WWC used 3 steps to evaluate RCT and QED studies. So the first step would determine whether the study use RCT or QED, whether a random process was involved. And then the second step would be sample attrition. So it's the combination of overall and differential attrition high. So here is like overall attrition and differential attrition. So in the next sections, we will talk about, in the next slides, we will talk about what is attrition and what is overall and differential attrition. And then the third step would be baseline equivalence. So whether equivalence established at the baseline for groups in the analytical sample. So for a study, if a study use RCT design, yes, then go to the next step. So WWC will check whether the sample attrition, the overall and differential attrition is high or not. If it is low in both overall and differential attrition, then WWC will give the rating for those will rate that study as meet standards without reservation. However, if a RCT has a high attrition rate, I mean either in overall or differential attrition, then the highest rating for that RCT would be meet a WWC standards with reservation if the baseline equivalence of the high attrition RCT, if those high attrition RCT can establish the baseline equivalence for their analytical samples. And for the studies which does not involve a random process, that is no. So go down here. So those studies, I mean, the QED studies have to demonstrate baseline equivalence to be eligible for meet standards with reservation. Otherwise, this study would receive a group the rating as not meet WWC group design standards. So next we will talk about what is RCT. So RCT uses a random process to assign unit. So types of unit include, for example, teachers or students, or cluster of individuals such as classes or schools. So here is like, for example, what is individual as teacher or student is because like the intervention unit is intervention units are teachers or the students. However, if in a school, for example, like in one study, the intervention unit is students, but the randomized unit is the teacher. So the unit, so it is the cluster RCT because the students were nested in the teacher or in the classroom. And then the next one is well-executed randomized creates groups that are similar on observed and unobserved characteristics. Therefore, observed differences in outcomes are due to the intervention, not pre-existing differences between the groups. So we can attribute the difference we find in the outcome to the intervention. So like here that the participants were randomly assigned to treatment, the intervention group, and the comparison. So this group and this group share similar on observed and unobserved characteristics. So the next question is, what is the well-executed randomization? So the study assigns the units entirely by chance. So assignment based on factors such as last name, birthday, or class schedule is not random. These factors do not rely solely on chance. So the unit, for example, the students will randomly, like you can flip a coin or use a random number generated in Excel sheet to assign your participants to treatment and control. But if you use the class schedule to assign this class is a treatment and that class is a control, then this factor, I mean the class schedule are not like realized solely on chance. For example, the class started at 3 o'clock, 3 p.m. maybe in the math, for example, the math class they started in 3 p.m. Like if you want to assign this class to treatment, probably all or most students in that class have another, for example, like a music or PE class or some special activities. So if you assign students based on their class schedule, it is not randomization. And then another criteria for well-executed randomization is every unit has a chance of being assigned to each group. So purposefully, group assignment made to accommodate specific factors such as students' needs do not meet this criteria. For example, you have a group of students and you say, oh, I want to assign more students who are on free and reduced lunch to the treatment group. So that is not fair for those students who were not on free and reduced lunch, because students on both conditions do not have same chance of being assigned to each group. So here I also want to emphasize that random selection is different from random assignment. So random selection is related to sampling. So it's mostly related to external validity. So we can say that random sample can better represent the larger group from which they are drawn. For example, your target population is all the undergraduates in TAMU. So you randomly select 120 students from all TAMU undergraduates. So this 100, you expect those 120 students represent the whole TAMU undergraduate students. And then you randomly assign 120 students to treatment and control. So it is more related to design. By definition, it's whether it is an experimental design, that randomization was conducted at the student level, and the random assignment is most related to internal validity, because we randomly assign students in either condition which helps us to ensure that our treatment groups are similar to the control group before the intervention starts. And here is the structure of research that holds all elements in a research project together, easier to explain with the design notation. For example, we use O to represent observation or measures like a pre-test or post-test. And we can use X to present treatment group. And then we will see like how many groups we have. We can have one treatment, one control, or two treatment groups and one control group. And then we have assignment to two groups, whether we use randomization. So here R, N, and C represent different meanings that we can see in the next slide. So here, R here means participants were randomly assigned to treatment and the control group. And the O, the vertical alignment of O's shows that tests are measured at the same time. And O's here means pre and post, indicating different waves of measurement. And this X representing the treatment. So this is the treatment group. And so we can see there are two groups. One is treatment, the other one is control. And here is the time. So here probably we have randomization, pre-test, intervention, and then post-test. So I'll use Project LRV as an example. So we select all districts with 6,000 enrollment and select all schools with 80 plus ELs in 2011 to 2012. So this can help us like those are our target population, the campus with high percentage of English language learners. And then we categorize schools by prior English achievement and cluster schools in group 3 by district, then by percentage of SES and percentage of English language learners. So you may say here is like in a group 3 by district, because we know district one district is different from another district. However, within one district, schools may share more similarities, but there are differences among schools. So by clustering a group of 3 schools that have most matched number of TOPAS rating, percent of SES, and percent of English language learner, so we can say that this group, one group of three schools within one district can share most similarities. And then within that group of 3, we randomly assign schools to different conditions. So in Project LRV, we have 75 schools. And then we have 25 clusters. Within each cluster, we randomly assign one school to treatment 1 and treatment 2, and the third one is control condition. So back to the design and the rating. So certain RCT are eligible to receive the highest rating, that is meet standards without reservation. This is the highest WWC standards that showing the confidence that treatment, the intervention causes the observed effect. So RCT falls into one of two groups to be, for example, the first one is like this study must maintain the integrity of random assignment. So this true randomization was conducted before the intervention starts, and the study must have low attrition. So if a study is RCT, the real true RCT, and have low attrition, this RCT can receive the standard meet standards, can receive rating of meet standards without reservation. If the study have high attrition, that study must demonstrate equivalence to receive meet standards with reservation. So the
Dr.
next,
Tang, Dr. Tang, can I add something here?
Yes.
Just as a practical kind of thinking about this and setting up RCTs, when we look at what she just talked about, that they fall into two groups, that the study must attain the integrity of the random assignment. And we think about when you're recruiting school districts for your projects and studies, what that really means for the true random assignment, the randomization, is that you're recruiting all these school districts and they're signing on not knowing what their role is going to be yet, right?
Yes.
So for example, in Project Listo, we recruited, let's say 70 school districts, and the conversations with the campus leaders and the school district superintendents, we had an MOU and they understood that there was a treatment and a condition, and they signed on for that MOU, an agreement to participate, not knowing yet which role they would be randomly assigned. So that's something to think about in your recruiting and conversations, that you explain the design in a way that, the school district understands what they're signing on to. And, they're like, fingers crossed we get the treatment, but we understand, to emphasize also the importance of that control or comparison group for the experimental study.
Yeah, thank you, Dr. Guerrero. And also in Project LV and also in Project Listo, the randomization was conducted by our external evaluator, Johns Hopkins University.
Good. Shifang, before you move on as well, so we've got everybody who is graduated 10, 15 years ago, PhDs, right through to people in their first semester. Can you just talk just for 1 minute about what is What Works Clearinghouse and why it's important and why our work needs to go there and what impact that work then has once it's there? Can you just speak on that for a second for me, please?
So to WWC standards, like right now, if you want to apply for the federal fundings, so you have to demonstrate at least 2 studies with moderate evidence and receive WWC standards with reservation or without reservation. So there's really a long. I read it yesterday. It's like 10-15 pages for elaborate that. And also based on what I read for ESSA, for schools to receive findings, they have to be rated as tier 1 and tier 2. So to be rated as tier 1 as tier 2, they also have to be meet the WWC standards with or without reservation. So it's like a reference for us as a researcher or practitioners when we want to design an intervention study.
So may I join for just a second? This is Beverly. Excuse me, Dr. Tang, but the WWC is What Works Clearinghouse, as she has mentioned, and you can find that on ed.gov website. And there are many studies, there are studies in different categories that are listed on there. And so they are sort of the watchdog of the research. And so this is what they consider. Many researchers across the country don't, but the government considers this to be gold standard research. And the goldest, I guess the most gold, would be the RCT, the randomized control studies. They are publishing some mixed methods as well, but for now, that's what they're doing. So I think that Dr. Etchels put that in there, and IES, the Institute for Education Sciences, actually oversees the What Works Clearinghouse. And this has been around for probably almost, would you say about 20 years, close to 20, maybe 15. So anyway, I just wanted to mention that. And you can find studies in there and sample studies. We have 5 studies that are in WWC. There are 2 that are recognized, 3 others that were reviewed. They are there. But the 2 that are recognized are one is with reservation, one is without reservations. So it really, it's okay if it's without reservations or with. It's you've seen what Dr. Tang shared with you, what the differences are. So anyway, it's good to be recognized just to have a study reviewed, even in what's clearinghouse. Thank you.
Thank you, Dr. Irby.
And moreover, it's good to cite those studies in your work as well. It shows that you're looking at the cutting edge of what the government's saying is working as well. So if you're trying to put something into a top journal, it's always good to have a look in what works for what's being talked about, who's talking about it, who are the names that are being talked about. Look at their research. It's a good starting point to lift off from. Good. That's time.
Yes.
I know.
Yes, and I also want to share with you that right now we are preparing a manuscript that use the data from Project LRV, and when we drafted the methodology and the result part, we try to incorporate all the components that I mentioned here, like random assignment, attrition, and baseline equivalence, to demonstrate, like during the writing process, we want to demonstrate that we have this component. So later, if WWC see our studies, then they can see our that paper. They say, oh, okay, so you all have this, and we hope that we can receive the meet standards without reservation and with moderate intervention effect. So next, we come to the quasi-experimental. So quasi-experimental design is very similar, like the RCT design, except they do not have the random assignment. So it may jeopardize the internal validity. So we still have some method to control. For example, we can select and scheduling measures, and we can conduct matching, and we can also decide the kinds of comparison groups to which the treatments compare, and also some aspect of treatment like reversed treatment. So all this we can control over when we conduct quasi-experimental design. So for quasi-experimental design, or QED, they compare, they use this design does not use random process. So researchers may use different approaches to identify groups. And according to WWC, QE must demonstrate equivalence because they may have observed or unobserved differences between groups before intervention starts. When baseline equivalence met, then this QED study can receive meet standard with reservation. So QED are eligible to meet standards with reservations. So the rating means WWC has a lower degree of confidence that the intervention caused the observed effect. So to receive this rating, this study must demonstrate baseline equivalence. Otherwise, this study will be rated as does not meet WWC standards. So next we will talk about attrition. So attrition is a loss of sample during the course of a study. So it occurs when individuals initially randomly assigned in a study are not included when researchers examine the outcome of the interest. So those participants were randomly assigned to different conditions and may take pre-test, but they do not have the post-test as the outcome. So attrition is a common issue in education research, and it occurs for many reasons. So here I list common causes for attrition. So it may participants drop out of the study following random assignment and lack of consent form and inconsistent or incomplete school records, and we are unable to locate where is the participant, or the participant refused to like take the test, so we can't collect the data, and or being absent or unavailable on the day of data collection, on the testing day. So here is like this figure shows that these are our eligible sample, and we randomly assign to intervention group and comparison group. So at the beginning, during the random assignment, two groups have similar characteristics at the baseline. So difference if there's no attrition. So the difference in outcome between two groups at the follow-up can be attributed to intervention. However, if attrition happens, the member of intervention group and comparison groups are not same, because you can see here we have more red and orange circles in intervention group at follow-up, and then we have more yellow and green circles in comparison group. So so at the time of follow-up or post-test, so attrition has result in the group that different from the initial group. So these two and these two are different, and these two are different too. So so to understand why attrition is important, so imagine the red circles and the orange circles are high achieving students, while the yellow circle and the green circles are low achieving students. So even you find that intervention group overperform the comparison group at the end of intervention, you cannot say it is because of the intervention. It is made because the attrition that caused the intervention group, the participants in the intervention group differ from the comparison group. So we can say that the observed effect of intervention is biased. So some differences in outcomes result from the difference from the intervention and the comparison groups due to attrition. So there's another example for calculating attrition. So as we mentioned earlier, we have overall attrition and differential attrition. Let's take this as example. So we have 100 students randomly assigned to treatment and control group. So we have 40 students in the follow-up stage and 45 in intervention group, and then we have 45 students in comparison group in the follow-up, in the post-test. So for overall attrition, so the total number of treatment and control groups at the end of intervention is 85. So use 100 minus 85 is 15. So 15 divided by 100, the overall attrition would be 15%. For differential attrition, so we calculate intervention attrition rate first. So that is 40, like 50 minus 40 equals 10, and 10 divided by 50. So that is 20% attrition in intervention group. And we do the same thing for the control. 50 minus 45 equals 5, and 5 divided by 50 equals 10% attrition. And then we use 20 minus 10 equals 10%. So 10% would be differential attrition. So any questions?
Shifang, do you report that in the paper? Do you go through all those numbers, or you just report that there was a 10% differential attrition?
Yeah. Yes, we need to report that. And this is like the randomization was conducted at student level. And like Project LV, the randomization was conducted at school level. So actually we report overall and differential attrition rate for at school level and also at student level.
Okay, great. John, do you want to go ahead and ask your question? It was a great question.
Yeah, I was just wondering if there's true random assignment, how do we get equal amounts in both groups? Because like if it's a coin flip, then it's not going to be 50-50 all the time, even though it should be.
Yes. I think first that you do not need to exactly same amount of students in both conditions, but there's a one way you can guarantee that if the number of participants is an even number. For example, you can generate a random number in the Excel sheet, and then you know how to generate, right? It equals random and parentheses, and then you will have a row with a random number, and then you sort the participants by the value of random number, and then you label them as 1, 0, 1, 0, so you can have exactly same number of participants in both conditions.
I think that there are two questions, and John, thank you for that question too. In the beginning, if you remember, in the LV, we had clusters of 3, and so those were all. And then we knew that we had to. Okay, so first of all, you have to look at your number, your N that you need to actually conduct the study, to have the power that you would need. I think that did you talk about that? I had to step away for a minute, Dr. Tang. Did you talk about that power issue? Yes. So anyway, where's the listo? Yeah, right here. So we knew that we had to have this 75 schools. I mean, we knew that with 150 classrooms, we knew that we knew the number that we had to have based on the randomizer. I forgot which one we are using, but at any rate, right now. But we knew this. So we first did that 6,000 plus enrollment, 80 plus ELs, etc. The year before, and looking at those school districts. And so then after that, we did those 75 because we knew that. And so we had these clusters of 25 because there were 3 in each, 3 schools in each district. And so we already knew that. And so we were able to do this and get the right numbers that we needed. So if a district fell in those in that category in step 1, but didn't have 3 schools, help me remember this, Dr. Guerrero, this is correct, I believe. If it fell there, but it only had, I'm just going to make this up, 2 schools, then that didn't work. But anyway, we used the clusters to get the numbers that we needed. So we already knew the numbers we had to have for randomization, and to make the study powerful, you know, to have the power, and then we randomly assigned to the condition. And we didn't, but Johns Hopkins actually did the randomization, but they knew that it would have to be an A. So A was treatment 1, B was treatment 2, and C was control. So it was A, B, C. And so they did a random assignment with, you know, Sunny Day Elementary and, you know, Happy Day and so on. So that's what they did. So it was equivalent. It is equivalent in the beginning. Now, along the way, that's the thing about the attrition in terms of the school and the classrooms. I mean, we may have had a teacher or a class or a school that said, you know what, we're overwhelmed. We've had these issues with so many teachers leaving and so on and so forth, and we just can't participate. I'm just making up something. So therefore, someone dropped out. So we do have some attrition, you see.
Yeah.
So that's what she's talking about. There may be attrition based on the school level data as well. So
Yes.
does that help, John? Or no?
I think it does help. I think the thing that I can't get in my mind is if it's random assignment, it's an equal probability of being in every single condition, right? So if you have 3 schools in a district, and let's say you flip a 3-sided coin, if that works, then there's a chance that they could all get the same condition, is what I'm saying. How do you account?
Yeah,
for
I mean, I just used that for an example. That was really not how we did that. Yeah, it's 3 per cluster.
Yes.
Yeah, you are right though, John, that you're never going to perfectly find 50 children of the same race, gender, height. They eat the same amount for lunch. They go to school using the same route. Like, you're never going to have a perfectly statistical random distribution. Why often in papers you'll see it was a sample of convenience, because they're trying to fudge it into that distribution to get what they want.
The sample of convenience also is the weakest type of sampling that we can do ever.
Absolutely, which is why we don't do it and we don't want to talk about it at all. But what we are looking for, and this is one of the standards that What Works has, that you need an RCT to kind of meet some of their standards. We'll cover that more, John, the RCT aspect. We do have one coming up about RCT.
Just back, another one is like and I want to emphasize is like the study like assignment entirely by chance, and have the equal opportunity to be assigned to treatment and control. It does not mean that you have to have equal number in both conditions. It's that they have the same opportunity to be assigned to treatment and control. And also they have like a suggested, like analytically you normally will have, for example, if you conduct a single level analysis, you should at least have like 25 to 30 participants in one condition. So if like when you have less or smaller sample size, you probably have a bigger issue of unbalanced sample size. But if you have a larger sample size, this unequal number of each condition would be minimum.
That answers my question. Thank you.
Thank you.
I think one other just thing to think about when we're thinking about design and trying to reach the RCT and having the numbers that you need to maintain your power is also the idea of oversampling, because we're going to lose participants, right? Whether a school drops out or a teacher drops out or students, drop out or whatever, for whatever reasons. So you purposefully, have more at the beginning, include more participants at the beginning, anticipating what your attrition may be. So one study, we were in a school district in the Houston area, and they had a history of about 30% mobility. So we knew, because we were able to look at their trend of mobility in that school district, then we needed to oversample, because we knew there was a high chance that we would lose a number of students that are mobile within that community, especially when we're looking at RCT and they're either getting this treatment or they're in this control. So even we have some kids that maybe started in one condition, but now their family moved down the road and they're in another school, they can no longer be part of our study unless that school happens to be in the same condition. So some of the other things to kind of think about in your design and your recruitment numbers.
Yes, and also I know that when PI apply for fundings, and they will report like based on, for example, the power of 0.7, and also they expect the effect size of the outcome of, for example, 0.25, And then based on this, like how many schools we need to recruit, and in each schools, how many teachers we need to recruit, and also how many students per classroom. So that's all the things we provided in the proposal, like at the beginning of the design such study.
I think for this LISTO, I think it was, if I recall, there were, I mean, it was about 60 was the number of schools, if I remember correctly, or 70. Anyway, we oversampled. I do remember we did that. Yeah. Mhm.
Hello, can you hear me? I have a question. Hello?
Yes, we hear you.
All right, so ideally we want the distribution to be evenly distributed, right?
Not necessarily, because randomization only consider two criteria. One is purely randomization, and then everybody got the same chance to be assigned to one of the condition, not the same or equal number in both conditions.
All right, so that's
okay, go ahead.
then back to the question that John asked. So he was wondering how we can get the equal amounts. Then, so isn't that what we want? So like, for example, that you mentioned, we have highly achieved students and we have like low achieved students, and we want them to be equally like mixed in both our groups, right? Is that an ideal situation?
Actually, it's like you conduct randomization first, then you examine you have the pretest. It's not, you have the pretest first and then you conduct randomization. And also, if, for example, like take another, like if, for example, if gender matters, let's say if gender matters, and you want to have exactly same percentage of girls in treatment and in the control. So you can do a blocking randomization. For example, you have 100 participants and 60 are female girls. So you block those, instead of randomly assign 100 students to treatment and control, you can randomly assign those 60 girls to treatment and control to ensure that you have 30 girls in treatment, 30 girls in control. And then you randomly assign the rest 40 boys to treatment and control. Then in your groups, in your treatment control conditions, you have exactly same boys and the control percentage if gender matters. And again, if you use this blocking variable, you need to incorporate that in your data analysis because you're blocking it. Like what we did for LRV, we use district as a blocking variable because we randomly assign a group of 3 schools to treatment 1, treatment 2, and a control. So district is a blocking variable, and we include that in our data analysis.
Here comes another question. I'm sorry to ask you too many questions. Like, so under what circumstances are you using the block one, and under what circumstances you don't use the block one?
It depends on whether you think this variable is important and will affect your intervention. For example, you have 100 students and 10 or 20 of the students were identified as special ed, and you know your intervention have a component targeting at a special ed, then special ed students, then you want to make sure that you have the same number or same percentage of special ed students assigned to treatment and control, because you think that special ed students will your intervention will affect the special ed students in a particular way. and you are interested to see or investigate the intervention effect on this subgroup. And then you want to make sure that each condition have the same percentage.
All right. So the picture you are showing right now is actually block assignment. It's not random assignment, right? Since you have exactly same number of each group, yeah.
This is not a blocking assignment. This is just a random assignment. It's not, this one is not using blocking variable. It's just randomly assigned to treatment control. Here is like and also keep in mind, like randomization helps you to have the baseline, like treatment and control participants have the similar level of observed and unobserved characteristics. So not necessarily these ones are high achieving and these ones are low achieving. And maybe there are other unobserved variables. Just like we mentioned in QED design, like even we use matching techniques to match treatment and control, or even we use some fancy ones like a propensity score matching. Still, all those matching based on the observed variables, not the unobserved variables. However, randomization helps us to wipe out the potential differences in observed and unobserved variables of or characteristics of the participants. Hope it helps.
All right, thank you. Thank you.
Thank you, Shou. These are great questions, and thank you for asking them. It's really important you ask these questions.
Any other questions, or I should move on?
Hello, I had like two questions. One is regarding the exactly 50-50 and randomized control designs like John pointed out. So when I flip a coin, there's a 50% chance of heads and a 50% chance of tails, right? And that ensures like a mostly equal distribution of participants in both random and control group. So my understanding is that even if it's not exactly 50-50, let's say if there are 100 participants, randomization will ensure that there is 49-51. That could be the case, right? And the second question is regarding individual randomization versus clustered randomizations. So if schools are like randomized in clusters, is there a chance for like bias? Because let's say all participants in a certain cluster school are like alike, and whereas individually, if they were randomized, that bias would have been removed.
Okay. So for your first question, like as I emphasize, only two criteria for randomization is entire by chance and also have the same equal opportunity, not the equal number of sample size in each condition. We do have some technique to ensure that. For example, you have 100 participants and you have their name in one column, and then in column A, and in column B, you use Excel to generate a random number, and then sort the random number from small to largest. And then you have the third number as 1010, because the random number was generated by random, so you don't know which number linked to that particular participant will receive a bigger or smaller number. So when you sort the random number, then kind of help you to get 50 participants, like labeled as one to one group, and then the other one to the control group. So we have the techniques to do that, but it does not necessarily mean that you should have exactly same amount of participants in one group or in both groups.
Yes.
Okay, and then back to your second question, you are saying that schools are alike, but the participants are different?
No, I'm saying, for example, if you do cluster randomization and if you randomize one cluster of school to one intervention and the other cluster to the control, let's say like in the intervention cluster, maybe some school districts are alike. And so there is less heterogeneity in that aspect. So is that a problem? Or like how does randomize, like cluster random, I guess my question is, does cluster randomization impose risk of bias more compared to individual randomization?
So ethnically, first, like randomization at the student level, we probably cannot do that because we can like pull out one student or couple of students one classroom, so and then assign them to treatment and control, and the so it's more ethical to conduct at the school level or teacher level. And another thing is, for example, in Project LRV, we matched schools in three based on three criteria: school level English achievement, like TOPAS rating, and then SES and English language learner, the percent of English language learner. So we match three schools. Then these schools share similarity at the school level, so they are similar, and then we randomly assign the schools to different conditions. And we're hoping that since at the school level the characteristics are similar, then that the school level characteristics are aggregated by student level. So we're assuming that students at each school share more similarity, then the schools do not have similar rating of TOPAS, ELs, and SES in another cluster. And I also want to emphasize that if during the randomization we use blocking of variable, let's say in Project LRV, we pre-test and post-test the students, and we examine the treatment effect on student achievement in the post-testing. However, we use HLM hierarchical linear model using in that analysis, we used a randomization unit, which is school, as the level 2 unit. So students nested in school while randomization was conducted at the school level, which justify the cluster effect. And this is also suggested by WWC.
I see. Thank you so much.
Thank you for your question.
Good. And thanks, Shifang. And I'll just say real quick, I know a couple of the new folks might be a bit nervous about asking questions and where that takes the meeting, but this is the point of these meetings. I can tell you now, I've sat in so many stats classes and methods courses, and I've sat there and I've gone, okay, like I understand the concept. The second I've gone to do it in actuality, in my actual job, and then I've gone, the what now? that has reoccurred so many times, and I'm sure everybody here has had that feeling of, I heard what you said, but when I go to do it in practicality, the realities of it look different from what I learned in class. And this is where the rubber meets the road, actually working in a grant, actually doing grant work and seeing how this plays out in reality. So thank you so much for asking questions, and thank you so much, Shifang. We have about 5 minutes left, just to be aware of the time and what we can do in that time.
Well, I haven't finished yet. I just I still
okay,
have.
Keep on going, Shifang. Keep on going.
Okay. So here is WWC used two attrition standards. So one is conservative attrition standard, the other one is liberal attrition standards. So when you see the yellow dot here, so with 15% of overall attrition and 10% of differential attrition, if WWC applies conservative attrition standard, so this yellow dot located in the red zone, so which is will be rated as have high attrition. However, if WWC protocol used liberal attrition standard, this yellow dot will be located in the green area. so will be considered as low attrition. So there's another picture for this. It's like the yellow zone is an unacceptable threat to bias and cautious, however tolerable threat of the bias under optimistic assumption, and the red zone is unacceptable for both protocol. And there's another table I want to show you. Like here, you can see overall attrition. Overall attrition and overall attrition, and this is differential attrition, and here is when cautious boundary applied, and this is optimistic boundary applied. So here you can see here, like if you have a study, if your study have like a 7% of overall attrition, so the differential attrition between treatment and control should be less than 6.3% when cautious boundary is applied, while it can be like lower than 10% when optimistic boundary applied. And you can see here, like when you have higher overall attrition, and you need to have lower differential attrition between like treatment and control. See here, so if you have 50% of students withdraw at the end of intervention, then the difference between treatment and control of the differential attrition should be less than 10% with a cautious boundary and 3.7 with optimistic boundary. So this is the table, and this is the flow chart as a reminder. So we have RCT here, RCT and QED here, and we have sample attrition, overall, and differentiation, and then we will talk about baseline equivalence. Matthew, remind me if I need to end.
Stay the course, Shifang.
Okay, so another question is like, what is baseline equivalence? So WWC uses term baseline equivalence when determining if the intervention group, those that receive intervention of interest, and the comparison groups did not receive the intervention, like business as usual, had a characteristic that was similar enough, equivalent at the start of the study. That is the baseline. So WWC requires that RCT with high attrition or compromised random assignment, so that is not authentic randomization, and our QED design, so 3 types of studies, they must demonstrate baseline equivalence to be eligible to receive meet standards with reservation. So why does baseline equivalence matters? So when 2 groups are similar at the start of the study, that's the baseline, and after that, the only difference between the groups is that one receives intervention and the other does not. So it's reasonable to conclude that any difference in the outcome are measured at the end of the day, end of the study, are caused by the intervention. And however, if 2 groups are different at the baseline on key characteristics that could influence the outcome, the effect found at the end of the study may be due to the difference that already exists at the beginning. So let me show you this. So this is at the beginning after the randomization was conducted. So you have similar characteristics. However, here you'll see that we have more oranges and red here, and more yellow and green here in the comparison group. So the baseline equivalence was not. So you check the baseline equivalence not based on this group of people, but actually on the group of people who stay till the end. So it's the pre-test scores of this participant. You need to demonstrate the baseline equivalence of your analytical sample who have both pre and post test scores. So this is the last slide. So how we calculate? So for example, we have the baseline mean, the pre-test of the intervention as 90 points, and then we have baseline mean of comparison group. So you use 90 minus 82 equals 8, and then you have the standard deviation 10 here and the 10 here. So probably you should have the pole standard deviation as a 10 too. So you use differences in means and divided by pole standard deviation. Standard deviation that is 0.8. And then you refer to WWC standards here. So you need to have absolute value of the effect size less than 0.05. So you establish the baseline equivalence without the need to include pretest as the covariate. However, if your baseline equivalent, the effect size of your baseline equivalence is the absolute value is between 0.5 and 0.25, which means you still demonstrate some level of baseline equivalence. However, statistical adjustments are required to satisfy baseline equivalence. Normally, you need to include pretest scores as the covariate. And if the study, the effect size of baseline is bigger, the absolute value is bigger than 0.25. So WWC will consider in this study the treatment and the control groups do not demonstrate baseline equivalence. So some acceptable method of statistical adjustment, for example, we can use regression covariate adjustment, including covariate in a hierarchical linear model, like pretest at the school at student level, although we use school level or teacher level as the randomized unit. And also we can use analyze of covariance like uncover to use pretest as a covariate. So that's the end.
So Nilsa, sorry, had the question, which I think is the third box here. So what happens with your study when it does not statistically meet baseline equivalence? Do you just delete it and cry, or there's something you can do with it? Or so what if the post-test groups are no longer equivalent? What happens with your study then?
Like the absolute value of effect size bigger than 0.25?
Yeah, her question was, what happens if after significant attrition you end up having, for example, 9 girls in one group and 1 girl in the control group, and the study is about gender? So now there's significant differences between the demographics of the group. So they're no longer in terms of what they look like. There's not homogeneity.
Oh, okay. You mean that previously you have like a same percentage girls and boys in both conditions, and then towards the end, then you have unbalanced.
Yes.
Right. Still, it determines first. You need to consider whether gender would be a factor that you think will affect your intervention.
Yeah. In this case, it would be.
In this case, it would be. And do you have in this case, if it would be, then first you will consider whether you have high attrition, right? So you can still like conduct analysis and incorporate the gender as the categorical variable in your analysis, but there's nothing you can really do, because if the participant withdraw, they withdraw. You have to state it as one of your limitation. You still conduct the analysis, and of course, based on their standards, this would not meet the standards with or without reservation. But you still can
if that
write
were to happen,
it up.
then it wouldn't meet the What Works standards, and you wouldn't be able to publish it in What Works if that were the outcome, right?
If it does not meet the standards, you still can publish that. There's a lot of studies do not meet the standards. But the standards is something you need to keep your mind when you design a study.
Okay.
And implement the study. because I have to say that an RCT is very expensive. It's really hard to implement. You need to build connections with schools, and you need to have the access. You need to administer tests. Even in QED, it's the same thing. It's not an easy type of research design. And also you cannot control, like you cannot force any participant say, hey, you should not withdraw. That's not right. So they withdraw and they move to another school, and they're sick on the testing day. There's a lot of things we cannot control. And I remember in Project LRV, and some tester, like some students were absent on the testing day because in LRV we administer Woodcock Monell. It's an individual testing. So maybe after 2 or 3 days, the tester went back to the school and tested students again. But think about if it is a group testing, probably the tester may not have, or some project may not have the money to support the second trip. There's a lot of things we cannot control. And at any time, the participant can say, no, I don't want to take any test.
Absolutely. Good. So Shifang, what I'm hearing, you follow the steps that you presented in your presentation today, you'll be all good. There's still a lot can go wrong with an RCT and trying to look at the variables. And it might be something that centers like ourselves, we would do with multi-million-dollar grants. It would be something that would be very difficult to do as a dissertation topic with one person trying to research this alone. To do all the steps and have all the connections that you need is more something that centers would do with grant money than an individual would try and do by themselves. You'd be climbing a steep hill, is what I'm hearing from you. Good. Okay,
Yes.
thanks. I think we are out of time for today. Thank you, Dr. Tang. This was a wonderful presentation. We appreciate you working on this. You've shown me this now, I think 3 times, and I learn something every time I see it. So I'll be watching this video again. All of the paths will be in a folder. You can go through and watch all the ones that you missed before you were employed. It's not your fault. So you can go back and watch those, and we'll have this every 2nd and every 4th Thursday of the month. So on your calendars, you've been invited, those folks that are new with us, and feel free to watch these later or attend as you can. But apart from that, thank you so much. We will see you all later. Have a good afternoon. Thank you, Dr. Tang.
Thank you. Thank you. Thank you, everyone.